Here's an example of factoring by grouping. I know that it might work for this one because there are 4 terms involved in my polynomial. None of the later ones will deal with 4 terms, so the only method that might work is that factoring by grouping. So what we're going to do here is we're going to separate this polynomial into 2 groups, the first 2 terms and the second 2 terms. And I usually just draw these little indications of which ones I'm grouping together. And what we're going to do is literally just pull out the greatest common factor out of the first group and by itself the second group. So between 6xy and 15y we can factor out a 3 and a y. That'll leave us behind a 2x minus 5. And in the second grouping, the common factor between 16 and 40 is 8, but we're going to have to take into account this negative sign here. So by rule of thumb, if the second grouping starts with a negative, you're going to factor out a negative no matter what. And then the 16 and the 40 will let us pull out an 8. So we're going to pull out a negative 8 out of the second 2 terms. And then leave behind everything with division. Especially when you're pulling out a negative, you've got to be careful of the sign. So negative 16x divided by a negative 8 is a positive 2x. And a positive 40 divided by a negative 8 is going to be a negative 5. We know this method works because out of these 2 terms that are left, they have a common factor of 2x minus 5. So we're going to pull out the 2x minus 5, and what's left behind is going to be this 3y, and very important, that sign there is going to be 3y minus 8. Now, if this method didn't work right off the bat, more than likely what you would have to do is switch using the commutative property, the 2 middle terms, and then try the grouping and factoring again. If that doesn't work, then this method is not going to work at all to factor this, and we can pretty much consider it prime. And that's it. We're done.